Okay, welcome to today's daily maths problem. A fairly straightforward one today. I've given you a slightly large version of the diagram underneath just so you can see exactly what is happening. You can see a circle is inscribed inside a square. So inscribed means just touches a square, just fits around the circle. And then I've done another circle around that square itself. And the question is, what is the fraction, or in other words, what percentage of the larger circle is the smaller circle? So fraction, percentage, either is fine by me. Have a think about the question. I think this one's a pretty straightforward one. So yeah, 1.5 out of 5 is probably what I'll give it. So not the most difficult, but nice little question to give it a go. Have a go. I'll be back in a minute or so. Okay, so how did we do? Again, I think there's a few ways of doing it. And as I'll probably often say in these videos, if you do it a different way, that is absolutely fine. Not a problem at all. It is just a way that works, that's showing some good rigorous maths. Now, to state the obvious, we have circles, and so the area of a circle is going to be pi r squared. And whenever we do a circle question, it's about trying to find out a radius. We have no measurements at all. So therefore, that means we can apply our own. So we could call something 1 or 2 or x or whatever it might be. I'm going to choose to go with x because sometimes that just makes it slightly easier so I don't get lost with different numbers, but complete preference. So I'm going to say the side length of the square is 2x. In other words, x to the middle, x to the end. And the reason I do that is because if this is halfway up the square, it means the radius of my inner circle is going to be x. And therefore I can say the area of the inner circle is going to be pi x squared. So far, so good. The outer circle is where the difficulty comes, because I need to somehow work out in relation to x the length of the radius. And the thing to spot is it's hard to go straight up, but if I go across over here, I can find out that length. And the reason I can do that is because I know this length here, so I know my first radius is x, and I know this length here is x. So therefore I can say the radius, so I'm going to call it the radius of the large circle, is going to be, just using Pythagoras, x squared plus x squared, which is going to be 2x squared square rooted, which is going to be the square root of 2x. So therefore that means the area of the outer circle is going to be pi times root 2x all squared, which is going to be 2 pi x squared, and therefore I've got both the things I need to measure. Let me just tidy that up so it's more readable. And therefore the question wanted to know what is the fraction of the outer circle is occupied by the smaller one. In other words, what's the fraction of the smaller one over the inner one? So therefore I need to work out the area of the inner divided by the area of the outer, which is going to be pi x squared divided by 2 pi x squared. Lots of cancelling, and that just leaves it with a half or 50% or whatever I might want to write. Technically it says fraction, so a half is the right answer. Again, reasonably straightforward question today. Nice little question, can be done quite quickly, but hopefully you all did very well. I'll see you tomorrow. I think tomorrow we might try a little bit of number theory. We'll see how that goes. Thanks all, like and subscribe please.